All right, so we're gonna go back and talk about the solubility and precipitation in terms of equilibrium perspective. Okay. Right. At this point, I'm sure you know that silver chloride is not soluble in water, right? If you remember group 7, so group 7, chlorine, bromine, iodine, precipitate with silver, mercury, lead, and copper, right? So yeah, they precipitate out right here. And sodium chloride, which is solid, you guys know salt dissolved in water. Okay. So one is not dissolving in water, the other one is dissolving. But the similarity is these two compounds, two ionic compounds, they form what they call solubility equilibria with water. Let's take a look. These are similarity. So the equilibria that I'm talking about is right here. At the beginning, when you add, let's say, sodium chloride, you add into it, right? So the surface so parts of sodium chloride will go into the water, are dissolving, right? So at the beginning, the rate of dissolving is higher than the rate of formation. And once there are more sodium chloride floating around in the solution, some of them will come back and form the solid back on. So basically, the sodium chloride are in equilibrium with in solid form and in solution. These are equilibrium. Same thing with silver chloride, which is not soluble in water. The silver chloride ion are in solution, and we also got silver chloride as a solid form. Then they are also in equilibrium. The only difference between silver chloride and sodium chloride is the extent of solubility. Okay, they form equilibrium in water, but the extent of silver chloride is really low. So we use KSP to show the equilibrium with water, right? So in water, dissolving basically. So KSP, or because the solubility product, equal to concentration of silver ion times concentration of chloride ion. Ignore the solid silver chloride, right? And KSP of silver chloride is really, really small, 10 to negative 10, which means that this equilibrium go backward, favor the formation of solid silver chloride. But sodium chloride favor formation of the product. So that's 27.66. All right. So I got some KSP value of water insoluble compounds. So it's really low. Take a look at solubility product, really low, 10 to negative 10, 10 negative 13, 10 negative 17. And yeah, the rest you can see right here. Yeah, none of these are soluble in water. Okay. All right, so quick simple right here. A particular saturated solution of silver chromate has concentration of silver, concentration of chromate. What is the value of KSP? Well, write out the dissolving equilibrium first, right? So we have silver chromate, look like that. Dissociate into silver ion and chromate ion, so 2 on the silver. All right, you can write out KSP as concentration of the product, so silver square, and chromate ion, just that. All right, looking for KSP, so we need to know the concentration of silver ion and the concentration of chromate ion. Do we know that? Yeah, these two numbers. Right? All right, plug in. So this is silver square and then chromate ion. Right, that's to the first. Do the math right here. 1.1 times 10 to negative 12. Okay. All right, super simple there. All right, let's do some practice together on the next video, okay?